Hello folks, I am Satya from Pi Wizards. First of all, I would like to thank you for purchasing this course. Let me take you through the learning outcomes of this course. After completing the course, you will know how to assemble and boot up the Mini Pi, how to use common Linux commands, the basics of Python programming, how to create a game using the Raspberry Pi and Python, how to interact with the Raspberry Pi hardware by building a Christmas tree lighting project. Do not panic when you see several lines of code. With practice, you will find writing code in Python to be an enjoyable experience. If you need help with anything at all, I am here to help and guide you. Thank you. Welcome back. In this session, we are going to explore the Raspberry Pi. As you can see here, Raspberry Pi is a credit card size single board computer developed in the UK by the Raspberry Pi Foundation. The Raspberry Pi has a Broadcom BCM2835 system on a chip, which includes 700 MHz processor, Video Core 4 GPU and a RAM of 512 MB. It does not include built-in hard disk or a solid-state drive, but uses a SD card for persistent storage. You will be amazed to know that Raspberry Pi does not require 220 volt of AC power supply like PC. All it needs a 5 volt power supply. You can simply plug the mobile charger of a 5 volt power supply to power up the Pi. Remember, the performance of Raspberry Pi depends upon SD card, so while buying, take care that it belongs to class 10 or more. So here I am using 16 GB class 10 Samsung SD card in order to store the operating system and boot the system when the Pi is turned on. Since we cannot insert the micro SD card, I am using a SD card adapter to hold the SD card. Now let us connect the Pi to the display. What type of display is required to connect the Raspberry Pi? Raspberry Pi does not have a VGA connector. Instead, it has a HDMI connector. So if you have a monitor with HDMI port, then it's okay. Otherwise, we need HDMI to VGA converter in order to connect to VGA port. Most monitor comes with VGA port. Hence, we will be using HDMI to VGA converter. In order to see the display, I am using LG 16-inch monitor. Keyboard and mouse is required to interact with the Raspberry Pi. With this, we complete the basic hardware requirement for the Raspberry Pi. Now, if you want to use the Raspberry Pi to connect to the internet, you can either use RJ45 LAN cable or a USB Wi-Fi dongle to access a Wi-Fi network. Sometimes we need a USB flash drive in order to transfer data to and from Raspberry Pi. But we have only 2 USB ports, and right now the ports are dedicated to keyboard and mouse. So in order to solve this problem, we will be using USB extension hub to connect to other USB devices. This device comes with external power supply. Hence, it does not use the Raspberry Pi 5 volt power. With this, we complete all the hardware requirement to assemble a Raspberry Pi based computer. Now, let us assemble all of them. When the Raspberry Pi appeared in 2012, few could have anticipated how popular the Raspberry Pi would be. In the years after its release, the Raspberry Pi has become the most popular single-board computer on the market and excited many developers and students. The Raspberry Pi is a small, bare-bones computer developed by the Raspberry Pi Foundation with the intention of providing low-cost computers and free software to students. The ultimate goal is advancement in the education of the adults and children, particularly in the field of computer science and related subjects. The allure of the Raspberry Pi comes from a combination of the computer's small size and affordable price. Enthusiasts envision using the small form factor PC as a cheap home theater PC or secondary low-power desktop. Institutions like schools and businesses could benefit from deploying a fleet of computers for a fraction of the cost of traditional desktop towers. The small size makes for an easy-to-hide computer that sips power and can be mounted behind the display with an appropriate case. It could also be used in niche applications like digital signage. While it will not blow away any recent hardware in performance, it does not make for a cheap secondary computer which could be useful for troubleshooting and researching solutions if your man rig fails to boot as well. Raspberry Pi is a low-cost credit card size computer that plugs into a computer monitor or TV and uses a standard keyboard and mouse. It is a capable little device that enables people of all ages to explore computing and to learn how to program in languages like Scratch and Python. It is capable of doing everything you'd expect a desktop computer to do, from browsing the internet and playing high-definition video to making spreadsheet, word processing and playing games. What's more, the Raspberry Pi has the ability to interact with the outside world. It has been used in a wide array of digital maker projects, from music machines and parent detector to weather station and tweeting birdhouses with infrared cameras. The biggest difference between something like the Arduino and the Raspberry Pi is in the intended usage. The Arduino is meant to be used as a development board with microcontrollers that will be programmed and then integrated into larger machines or electronics and allowed to run on their own. On the other hand, Raspberry Pi is meant to be used as a final product and operate as a traditional desktop computer. The Raspberry Pi 2 packs a lot of power into the same small frame that the Raspberry Pi has always had. But how much more bang do you actually get for your buck? Compared to Raspberry Pi Model B+, Broadcom BCM2835 ARM-v6 system on a cheap processor. The Pi 2 Model B has a new quad-core Broadcom BCM2836 ARM-v7 processor powering a single-board computer running at 900 MHz. The B+ single core ran at 700 MHz. So it is quite clear that the Pi 2 quad core running at 900 MHz is a beast in comparison. By having the next step up in Broadcom's chip range, the Pi 2's BCM2836 chip can push out Broadcom Video Core 4 technology at 250 MHz and has a 1080p decoder and encoder. The Pi 2 has 1 GB RAM shared between the GPU and the CPU, which is twice the amount of B+, running 50 MHz faster than B+ 512 MB SD-RAM at 400 MHz. You can now push 1.2 ampere to the Pi's 2 4 USB ports so you can connect power-hungry devices. To do this, however, you will have to use 2 ampere micro USB power supply instead of the usual 1.8 ampere 5 volt USB power source that the Model B+ makes use of and the Pi 2 supports. Other than that, the Pi 2 still has 4 USB 2.0 ports, uses a 40-pin general purpose input-output, takes micro SD cards for storage and has an Ethernet port too. There is also a CSI camera port and a DSI display port for connecting a Raspberry Pi camera and touchscreen display. The Raspberry Pi 2 runs on the same systems as the Model B Plus. So everything you have for the Model B Plus and older Pi boards will work without issue on the Pi 2. However, to really make the most of the added power that the Pi 2 brings, software will need to be resynced to maximize efficiency across the 4 cores. You will also have to download and install ARM version 7 of Raspberry Pi operating system, as the Pi doesn't support older builds. However, V7 works across all Raspberry Pi devices, so there is no reason to not update to it on older devices. If it wasn't for the extra RAM and the increased processing power the quad-core BCM2836 offers, the Pi 2 wouldn't be able to handle running an operating system like Windows, nor the likes of snappy Ubuntu core either. Comparing this to the B+, the Raspberry Pi 2 essentially solves the biggest problem that limited past hardware by adopting a quad-core processor. It is exactly the same price as Model B at $35, which is worth buying. The Raspbian operating system comes preloaded with helpful software, including the Ififany browser and even a free stripped-down version of the blockbuster Minecraft game created just for the Raspberry Pi. A central Pi store points you to more than 100 additional games and apps, including productivity tools like LibreOffice Suite. The Raspberry Pi Foundation goal with these devices is to introduce people to programming. However, and it shows in softwares that pre-installed on Raspbian. You will find versions of Wolfram Mathematica, Python program creation tools, and Scratch, an animation coding IDE for kids. The focus on teaching the basics of computer science permeates the entire Raspberry Pi experience, while the installer is well laid out and will get you up and running in mere minutes. You will need to roll up your sleeve and delve into the command line. Just getting this thing running in an educational experience in and of itself for people wind on Windows. Be warned, however, that getting the Raspberry Pi 2 up and running is likely to cost you more than $35 price tag, though you might have most of the accessories you need already. Here is a full list of what you will need to use the micro PC. A 5-volt micro USB cord capable of drawing at least 1200 mA from the wall. Any micro USB tablet charger should work just fine. And USB keyboard and mouse. A micro SD card with a compatible operating system installed. 8 GB works, but a greater storage amount would be better if you plan to save files, install additional softwares. An HDMI cable or composite video 3.5 mm audio cord, a monitor or television to connect to, an Ethernet cable or USB Wi-Fi adapter. You should probably buy a case to shelter the exposed board as well to avoid potentially damaging it. It performs admirably as a maker's tool and rocks as a teaching tool for budding computer programmers. Finally, it suits as a potential itty-bitty storage server or low-cost home theater PC. You still wouldn't want to use this for your primary computer. Not that the Raspberry Pi 2 is intended for that. The Raspberry Pi 2 answers a lot of requests made by the community and provides a stable and well-supported platform for hackers, makers, and learners to carry on making excellent projects for many years to come. Welcome back. Now we have a blank SD card and we want to install the Raspbian operating system. In order to do this, you should have a PC running Windows or Mac. In this lecture, I will show you how to prepare your SD card using Windows operating system. Just open your browser and type SD card formatter. Navigate to the first URL. On the left hand side of the web page, you will see SD card formatter 4.0. Below you can see the URL with both Windows and Mac. Click on SD formatter 4.0 for Windows download. Scroll the page below and click on I accept button. The software will start downloading. The software will be in zip format. We need to extract the file and save in a folder. Once you extract the file, you will find one single file named as setup.exe. Double click on that and install in the default directory. After successful installation, open the software SD formatter. You will see the option to choose a drive. If you can't see this, click on refresh. You will find your SD card drive. After that, click on option. You will find a small window titled Option Setting. From the drop-down menu, select the following: Format type, Full, Format size adjustment, On. Click on OK. And finally, click on Format. Now, your blank SD card is ready and we have to download Noobs installer. You might be wondering what Noobs is. Noobs stand for New Out-of-Box Software. It is the easiest way to set up Raspberry Pi for the beginners. It is much easier because you won't need network access and you won't need to download any special imaging software. Open your browser and search for Raspberry Pi. Navigate to the first URL. This will open the official website of Raspberry Pi. Click on Downloads. You can see SD card icon with title Noobs. Choose Offline and Network Install and click on Download zip. After successful download, extract the file in a folder. Let's name the folder as Raspbian. Just copy all the files and folder and paste in your SD card. Don't copy the folder itself. Copy the content inside the extracted folder. Otherwise, your Pi will not recognize the OS. We are done. Our card is ready. We just need to insert the card in the Raspberry Pi slot. Welcome back. In this lecture, I will show you how to boot up the Pi with Noobs and install Raspbian operating system. Connect all the accessories to Raspberry Pi and insert the SD card in the SD card slot and power up the Pi. On your display monitor, you will see a menu with a heading Noobs version and build date. Below that, you can see three options: Raspbian, Data Partition, and Raspbian Boot to Scratch. Double click on Raspbian to select it and then click on Install. You will get a warning that you are going to overwrite your SD card. All existing data on the SD card will be overwritten. Just click on Yes. You will see a rectangular screen with a message, Welcome to Raspberry Pi, and below at the bottom the progress status bar showing you the percentage of installation done. Just be patient, have some coffee and wait till the installation gets over. Hey, are you there? Installation is over. You will also be seeing the same message on the screen. OS installed successfully. Click on OK, the system will reboot. Once the reboot completes, you will see a menu with lot of options. Remember, the mouse will not work in this environment. We will choose one by one with keyboard arrow key. No need to choose the first option, Expand File System, because that has already been done as we are using Noobs installer. Come down to the second option with arrow key, change user password and hit enter. You will be asked to enter a new password for the Pi user. Again hit enter. Bottom of the blue screen, you will see a console prompting for enter new Unix password. I am giving the password as Pi in a small letter. You can give whatever you want. Don't worry if you can't see the given password displayed on the screen. For security reason, it will not be shown. Once again, it will ask you to retype the unique password. Type the same password again and hit enter key. You will get a message, password changed successfully. Hit enter key and you are done. You will again come to main menu. Come to the third option, enable boot to desktop scratch and hit enter. You will see a sub menu with three options. Come down using downward arrow key and select the second option, desktop login in as user Pi at the graphical desktop and hit enter. This option will enable Raspberry to launch graphical user interface upon boot. No need to make any more changes. Just hit your tab key of your keyboard 2 times and you will see the finish section gets highlighted with orange color background. Now hit enter key. You will be asked, would you like to reboot now? Just hit enter, ensuring the yes is highlighted with orange background, and the Pi will save your settings and boot with newly made changes. On successful boot, you will see the graphical user interface environment with Raspberry Pi logo. Welcome back. The Raspberry Pi uses Linux as an operating system. In this lecture, I will teach you common Linux command and show you how to use the console command line. Linux is an open source operating system. You don't have to pay anything for the usage of the same. Although the operating system is called Linux, there are number of versions of Linux in the marketplace, going by the name of Debian, Red Hat, etc. The one recommended by the Raspberry Pi Foundation is called Raspbian VG. LX terminal is used to type commands into the command line. You do this to install a new application and to configure the Raspberry Pi. Click on the launcher button located in the corner of the screen and a menu will appear. Again click on Accessories and select Alex Terminal. Now a black color console will appear with a dollar prompt. Here we will type Linux command and execute them. The first command is pwd, which stands for print working directory and shows you the directory you are currently in. Therefore, after the dollar sign in the terminal window, type pwd and press enter. As you can see, we are currently in home/pi directory. The next command we are going to discuss is ls, which is short for list, and this command shows us a list of files and directory within the working directory. Now type the following command and hit enter. This shows us list of files and folders in home/pi directory. Now let us see how we can install an application. Installing a new application is quite simple and easy. Installing new application requires the command line again. The command apt-get is used for both install and uninstall applications. Because installing an application often requires super user privilege, we should prefix apt-get command with sudo. The command apt-get uses a database of available package that is updated over the internet. The first apt-get command you should use is sudo apt-get update. This command updates the database packages. Remember, you will need to be connected to the internet for it to work. To install a particular package, all you need to know is the package manager name for it. For example, to install the Genie, an editor application, all you need to type in the following command is sudo apt-get install Genie is the package name. It will take a while for everything that is needed to be downloaded and installed. But at the end of the process, you will find that you have a new folder in the start menu called Genie that contains the application Genie Editor. Now, if I click on this launcher button and open the programming section, I can find a new application named as Genie. Genie is also an editor similar to LeapPad and other editors. So I am closing this application and I will show you how to remove this application. Sudo stands for super user apt-get, and instead of install you put remove command and then the package name GEANY. It will ask you, do you want to continue? Click on yes. Now click on the launcher again, go to the programming section. You will not find Genie. The Genie application has been completely removed. Thank you. The time has come now to start creating some of our programs for the Raspberry Pi. The language we are going to use is called Python. Python is an easy to learn language. At the same time, it is powerful enough to create several interesting programs. including simple games and programs that uses graphics. As with the most things in life, it is necessary to learn to walk before you can run, and so we will begin with the basics of Python language. The best way to learn a new language is to begin using it right away. So let's start up the program. This program is called idle, and you will find in the programming section of your start menu. In fact, you will find more than one entry for idle. Select the one labeled as idle 3. Now, what you are seeing here is Python shell. This is the window where you type Python commands and see what they do. It is very useful for experimenting, especially while you are learning Python. Just like the console command prompt, you can type in commands after the prompt, and the Python console will show you what it has done on the line below. Arithmetic is something that comes naturally to all programming languages, and Python is no exception. Therefore, type 2 plus 2 after the prompt. And you will see the result 4. Another example, type the following into the Python shell. You can see the result 90.0. Remember, here star means multiply and slash means divide. Python does multiplication before division, and it does division before addition. You can add some parentheses to guarantee that everything happens in the right order, like this. You can see the same result 90.0. The Python shell is a great place to experiment, but it is not the right place to write a program. Python programs are kept in a files so that you do not have to retype them. A file may contain a long list of programming language commands, and when you want to run all the commands, what you actually do is run the file. The menu bar at the top of the idle allows us to create a new file. Therefore, select File and then New Window. A blank editor will open with a default file name Untitled. This is a place where you can write n lines of code. Type the following 2 lines of code into idle. You will notice that the editor does not have the prompt sign. This is because what we write here will not be executed immediately. Instead, it will be stored in a file until we decide to run it. If you wanted, you could use Nano, Genie or some other text editor to write the file. But the idle editor integrates nicely with Python. It also has some knowledge of the Python language and can thus serve as a memory add when you are typing out programs. We need a separate place to keep all the Python programs we will be writing. So open the file browser from the Start menu. It is under Accessories. Right click over the main area and then select Create New and then Folder. Enter the name Python and click on OK. Next we need to switch back to our editor window. and save the file using the File menu. Navigate inside the new Python directory and give the file name as fuzz.py. And click on Save. The .py stands for Python Program Extension. To actually run the program and see what it does, go to Run and select Run Module. You should see the result of the program's execution in Python shell. It is no great surprise that the program prints the two words My First Pi and 2014, each in a new line. Whatever we type within the inverted comma under print command, the same is displayed on the screen. What you type in the Python shell does not get saved anywhere. Therefore, if you exit idle and then start it again, anything you typed in the Python shell will be lost. However, because we saved our editor file, we can load it again . Now, let's learn about while loop. A while loop statement in Python programming language repeatedly executes a target statement as long as a given condition is true. Now open an editor and type the following program. These two statements, print and count, both are under while loop. Come to the next line, remove indentation and type go to File, click on Save and give the file name as while go, click on Save. Click on Run and Run Module. You can see the value of count is printed from 0 to 8. Now come back to the programming section. I have assigned the value of count to be 0. So it takes the value of count from 0 and prints the value of count lesser than 9. So 8 is less than 9. So the value of count is printed from 0 to 8. And as you can see, this statement goodbye is not under while loop. It is in separate line. That's why goodbye is printed only for single time. Now let's learn about the decision making statements in Python. Decision making statement require that the programmer to specify one or more conditions to be evaluated or tested by the program, along with a single statement or multiple statement to be executed. If the condition is determined to be true, and optionally other statement to be executed if the condition is determined to be false. Now click on File and select New Window and type the following program. If space 4 greater than 6 full colon, come to the next line, type print open bracket double inverted comma true double inverted comma close bracket. Come to the next line, type print open bracket welcome to Python double inverted comma close bracket. Come to the next line, type print open bracket God bless you double inverted comma close bracket. Come to the next line, remove this indentation by backspace, type else full colon. Come to the next line, type print open bracket false. In the next line, type print open bracket double inverted comma open don't make a wrong assumption. Double inverted comma close bracket. Enter. Go to File, click on Save and give the file name as if example.py. Click on Save. In order to run this, click on Run and Run Module. You can see the output as false and the statement don't make wrong assumption. Come to the programming section. As per the condition, 4 is lesser than 6, but we have given a wrong statement, 4 is greater than 6, which is not true. That's why the else part got executed, because the condition is false. The Python compiler neglects the if part of the program. Now let's learn about the comparison operator. Double equal to checks if the value of two operands are equal or not. If yes, then condition become true. A double equal to B is not true. Now click on File, select New Window and type the following program. A equal to 21, B equal to 10. If open bracket A double equals to B close bracket full colon, come to the next line, type print open bracket double inverted comma open A is equal to B close bracket. Come to the next line, remove this indentation, type else full colon. The next line, type print open bracket A is not equal to B double inverted comma close bracket. Go to File, click on Save. Keep the file name as if example2. Click on Save. Now click on Run module. You can see the output as A is not equal to B because the value of A is 21 and the value of B is 10. That's why if we compare the value of A and B, both are different. Hence, the else part of the program got executed. Now, let's learn about random function. The random module provides a fast number generation based on the Mersenne-Twister algorithm. If you type x equal to random dot randint open bracket 1, 7 and press enter, you can see the error random is not defined, because in order to use this function random, we have to import the library for this. In order to do this, click on File, New Window, Import random x equal to random dot randint open bracket 1, 7 close bracket. Come to the next line and type print open bracket x close bracket. Since we have to print the value of x, we don't need to give inverted comma. Click on File, Save, give the file name as RAND, click on Save. Now go to Run and Run module. You can see the value is 4. Now close this window. Again go to Run and Run module. You can see the value 5. Because random function generates the number between 1 and 7. And each time you run, a random number will get generated. Now, if you want to take user input, that means you are assigning the value during runtime. Here runtime means when the program gets executed, which takes the value entered by user during runtime. For example, x equal to input open bracket close bracket type print open bracket x, press enter. So if I enter 4 will get printed. This means that whatever the value user will type, the same will get printed. Now you are packed up enough to build a new application. Let's meet together in project development phase. Thank you.
Hello learners, greeting from Macademy. Today I am going to show you how to interact with the physical world using Raspberry Pi. I have come up with a basic LED blinking project which is written in Python programming. By doing so, you will learn how to start with physical computing. Let me give you a brief description of the entire project. We will be using 3 LEDs, breadboard and jumper wire to make the connection. The LEDs will be blink in on and off pattern. You will also get the error-free source code so that you can quickly build the project by yourself. Let us gather the hardware requirements for this project. We need the following: Raspberry Pi model B, B+, or 2, 3 LEDs, 1 breadboard, 4 jumper wires. Let me give you a brief description about LED. A light emitting diode is a 2-lead semiconductor light source. It is a p-n junction diode which emits light when activated. The longer pin of the LED is positive and the shorter one is negative. Here we are using the latest version of Raspberry Pi 2 to build this project. You are free to use any model of Raspberry Pi. We will be using the GPIO pins of the Raspberry Pi to interact with the LEDs. Assembling the circuit. How to add the live and neutral wires. It is important to do this while the power to the Raspberry Pi is off or disconnected, as you want to avoid short circuiting at connector by mistake. The first thing you need to do is connect up the power and ground wire. As with most electronic projects, everything that connects with require a common ground, as we have shown it with a green wire. Since ground rails connection is still half of the breadboard, we have used a short wire to extend the ground wire to the next half. Assemble the circuit as shown in the diagram. The ground on the Raspberry Pi is physical pin 6. As you can see, the negative side of LED are connected to common ground rails of the breadboard, and positives are connected separately to the GPIO output pins 10, 16 and 18. I have written a Python program which will blink the LEDs in all on and off pattern. Before we execute this, let us explain you the code line by line. Import rpi.gpio as GPIO. Import time. We are using two libraries to enable the GPIO pins and use the slip function. GPIO.setWarning false. We are disabling the runtime warnings generated by Python compiler. GPIO.setMode.GPIO.board. The GPIO.board option specifies that you are referring to the pins by the number of the pin, which is the numbers printed on the board. GPIO.setup 10, GPIO.out. GPIO.setup 16, GPIO.out. GPIO.setup 18, GPIO.out. Here it means we are enabling all the GPIO pins which will be using to set up the LEDs. While true. A while loop is a control flow statement that allows code to be executed repeatedly based on a given Boolean condition. Passing true as an argument in the function runs the loop infinite times to blink the LEDs. GPIO.output 10, true. GPIO.output 16, true. GPIO.output 18, true. Time.slip. This piece of code contains the main logic of the program, enabling LEDs to blink. So the LEDs will blink for a second because of the slip function specified with 1 in the argument. Print LEDs are on. This will display the message on screen when LEDs are on. GPIO.output 10, false. GPIO.output 16, false. GPIO.output 18, false. Time.slip. This piece of code is disabling the LEDs from blinking, so the LEDs will not blink for a second because of the slip function specified with 1 in the argument. Print LEDs are off. This will display the message on screen when LEDs are off. GPIO.cleanup. And finally, when all the operations are over, we are cleaning up all the ports used in the program. Now click on the file and click on Save. Give the file name as LED. No need to add the extension .py as it will be by default. Now click on the Run and then Run module. We can see that the program executes successfully. If you get error, try running as root. Then we need to run the program in super user privilege. Close the idle editor and open the Linux terminal and type sudo space idle. This launches the idle in admin mode. Now execute the program again on Now let us do the real-time demonstration of our project.
In this lesson, we will be building a simple console-based game using the Python language. We'll call this project as the number guessing game. The objective is to create a game wherein the computer will think a number and the player will attempt to guess the number within 6 attempts. Okay, let us start writing the program. First of all, open idle, go to File, click on New Window. In order to generate a random number, we have to import the random function. Type import random. Now let us create a variable named as number of attempts and assign the default value to be 0. In order to make it more interactive, we will have the computer ask the player's name. Type print open bracket double inverted comma hello, what is your name? Question mark double inverted comma close bracket. In order to store the player's name, we should use the input function. The input function will take user input at runtime and save in a variable called myname. myname equal to input function. Now let's give the computer a chance to generate a random number between 1 to 20. The number generated using random function should only be an integer. Hence, we will be using randint. Number equal to random dot randint open bracket 1 comma 20 close bracket. We should have a variable to store the dynamically generated number. Hence, we will use the variable named as number to store these values. Now, let's ask the computer to communicate to the player that the system is thinking of a number. Come to the next line and type print open bracket single inverted comma well comma single inverted comma plus my name plus single inverted comma close comma I am thinking of a number between 1 and 20 full stop single inverted comma close bracket. We are going to restrict the number of attempts by the user to only 6. If the player is not able to find the number in 6 guesses, the game ends. We can easily do this by using while loop. While number of attempts less than 6 full colon. Come to the next line. Please remember that indentation is very important in Python. In Python, we don't have open braces or close braces like in other programming language. So all the statement under while should be indented. But here the idle takes care of this. Print open bracket single inverted comma take a guess single inverted comma close bracket. and whatever the user enters should be stored in a variable. In order to do this, let's take a variable guess equal to int open bracket guess close bracket. The input we capture comes in a string format. Therefore, we need to convert the string to integer format. That's why I have used int before this case. Now the player has already taken one guess. So let us increment the number of attempts value by 1. If you want to write the same code in a simpler manner, please use the following line of code. Here, both the line conveys the same meaning, so you can use either of them. Let's delete one of them. Now, let's check if the player's guess is less than the computer generated random number. If the guess is lower than the computer generated random number, then if the condition will be true and the statement you guess is too low will be printed. If guess less than number full colon, come to the next line and type print open bracket inverted comma your guess is low inverted comma close bracket. On the other hand, if the player guesses a number that is higher than the computer's random number, we will have the computer output that the guessed number is too high. Remove this indentation by a single backspace. Type if guess is greater than number full colon, come to the next line and type print open bracket single inverted comma your guess is too high inverted comma close bracket. Now, if the player is lucky, the guess value will be equal to computer generated random number. The moment this condition is true, we should stop the loop and come out of the loop. For doing this, we can simply use the break command in the Python language. Now the player will be informed that he has made the correct guess, and he will also be informed the number of attempts he took the guess to find the correct number. Since number of attempts is an integer variable, we have to typecast to a string. Remove indentation with the backspace. Type if space guess double equals to number full colon, come to the next line and type number of number of attempts equal to str, means typecasting to string open bracket and the same variable number of close bracket. Come to the next line, type print open bracket inverted comma good job comma inverted comma plus my name plus single inverted comma exclamation mark you guessed my number in single inverted comma close plus number of attempts plus single inverted comma guesses space exclamation mark single inverted comma close bracket. And finally, if the player is not able to guess the correct random number, the system should tell the player the actual random generated number. Remove this indentation and type if guess not equal to exclamation mark and equal to is the symbol for not equal to number full colon. Come to the next line. Number equal to I am typecasting the variable number to string again because it has to be printed. Print open bracket single inverted comma no full stop the number I was thinking of was space single inverted comma close plus number close bracket. Here we finished the code. Just save the file. Keep the file name as number underscore game and click on save. Now go to run and then run module. Here you can see our program executed successfully. So let's play the game. You can see there is an error in the program. It is showing guess is not defined. So let's find out where is the problem. We have to define this variable guess. The variable guess is capturing the user input. Along with that, we have to also take care if the player finds the number, we should break the loop. And this to statement should be outside the loop. Now save the program once again and run the program. I took a guess for 13. The program is saying the guess is too high. Let's take 9. The guess is too low. This means the number is between 9 and 13. It's too high. So I'm able to guess the number in 4 guesses. Each time you'll run the program, you'll get a different output. Let's play again. Here I lost. The number I was thinking was 7, says the computer. So this is a small console-based game. Thank you. Hi, welcome back. We have already built a gaming application, but it's virtual as you will only be playing the game on your computer. Now, let's make something that is tangible and in the real world. I'm talking about building a hardware project. Are you excited? Come on then. Let us build a Christmas tree light project using the Raspberry Pi. Here, I have a Christmas light. Let's open the box. This Christmas light has a control box with a button. Let's plug it to the power source and switch it on. You can see that it lights up. Now, when you click on this pattern changer button, we get another pattern of light. Each time you press the button, a new sequence gets generated out of a 8 set pattern of light. Looks cool, right? Let us open and see what inside the box and how this whole thing works. There is an electric circuit and the program is embedded inside the circuit. However, by just looking at the hardware, we would not know how long the program is and the logic used to program the lighting patterns. Here we are creating our own lights from scratch and we will write a Python program to control the GPIO pins of the Raspberry Pi. You might be wondering, what is a GPIO pin? GPIO stands for General Purpose Input Output Pin. These GPIO pins are located in the board of Raspberry Pi. I will show you where it is. As you can see, beside the audio video jack, the 26 GPIO pins are present. We will be using most of this pin to control the hardware. Now, let's gather the list of hardware that we will require to build this project. The first one is LED in 3 different colors: red, green, blue. If you are getting the bigger one like this, you don't need a resistance. This resistance is not required. And if you are getting a smaller one, then you need a resistance of 100 kilo ohms. We need 5 red, 5 green and 5 blue LEDs. If small LED, then 15 resistance and 15 LED. The second one is female jumper wires. In order to connect the LED to the GPIO pins, total jumper wires required 15. The third item we require is a single metal wire to solder the LED. Around 5 meters is enough. We would also require a soldering iron with solder wire and flux. This is the complete list of hardware we require to complete our project. Next, we need to assemble all this hardware. First of all, take a cartoon box and cut it from the middle in such a way that you can fix all 15 LED with equal space between them. This is my cartoon box where I am going to fix all the 15 LED. Now follow me step by step. We will follow the pattern RGB. This means red first, then green, then blue. Now look the LED carefully. You can see one pin is longer and one is shorter. The longer one is positive and the shorter one is negative. The same in the green one. Now fix the LED in the same pattern as I am doing. The positive to the left hole and negative to the right hole. Now come to the back side. The longer pin, which is positive, bend it towards the upper side. For each one of them. And negative to the downward side. I will show you how to solder one LED and rest you can do your own. I have soldered one wire to this LED pin. As you can see here, we have separate connection for the positive wires of LED and one common connection for the negative wires of LED. We will do the same for the remaining 12 LEDs. Now arrange the LED in the same pattern as I have done. Use the soldering iron to solder the wires to LED and at the other end point join the jumper wires like this. Just cut the jumper wires from middle so that the second part can be used with the other pin. Whenever you join the end point, don't forget to put a tape around it in order to avoid risk of damaging the Raspberry Pi. As you can see here, I have one common wire for all the negative pins. This black wire is common for all the negative pins and separate wires for each positive pins of LED. Now let us first write the Python code for this project. First of all, open idle in super user privilege. This is because we are going to use the GPIO pins of Raspberry Pi. For the purpose of security, the system does not allow an user who is not a super user to interact with the hardware. To open idle in the super user mode, open terminal and type sudo idle. This command will open idle in super user mode. In the file menu, click on new window. Let us start writing the program. In order to enable GPIO pins, we need to import GPIO library files. We also need to import the time library to use the time function. We need the time function to introduce some delay in the blinking of LED lights. The GPIO.board option specifies that you are referring to the pins by the number of the pin on the board, that is, the numbers printed on the board. Example P1. You can refer this diagram. The header provides 17 pins that can be configured as inputs and outputs. By default, they are all configured as inputs except GPIO 14 and 15. Out of these 26 pins, we will be using all the green pins and also the ground pin. Let us enable all the 15 GPIO pins that we will be using to build our project. Please write the pin numbers correctly. Copy and paste the same line for 14 times and only change the pin number. We will be defining functions which will take two user input and then process the function as per the input. Here, def keyword is used when we define functions. RGB is the name of function. The function takes two parameters. One is number of times and the other is speed. We also need a for loop to iterate the pattern. We will also print the status of LED blink. Let us use the print statement with the number of times it blinks. Now enable the pins completely so that the flow of current starts. GPIO.output is a function that takes two arguments. The first one is the pin number and the second one is true or false. True means current will flow. The method sleep suspends execution for a given number of seconds. The argument may be a floating point number to indicate a more precise sleep time. Here, the argument speed determines the number of seconds execution is to be suspended. Now, after certain delay, I am disabling the pins so that flow of current stops. Now, let us do the same thing for the other pins too. Always remember that indentation is very important in Python programming. Just change the pin number. Just do the same for remaining pins. Five pins to be true and the next 5 pins to be false. After every 5 pins, we have a delay of certain seconds. Our first pattern, which is RGB, that is first red, then green and then blue, is over. Now let us write another function which will generate the pattern one by one. Here number of times and speed are user input. Declare a for loop for iteration. Print the number of time LED blinks. Copy and paste the same line of code. Only change the pin number. Keep on changing the pin number till we cover all the 15 pins. Now we need to disable all of them at once without any delay. Copy and paste the same line without time.sleep function. Change the pin number of all the 15 pins used in the program. Now we have to revert the same. Copy all the lines above false and paste it once again. Change the pin number for reverse display. Copy the false once again to disable the pins at one shot. Change the pin number of all the 15 pins. Finally add time.sleep function at the end of the program. You will find that while disabling the pin as false, there is no delay, as there is no need of delay in this case. Now we have completed the code for the second pattern. Now let us generate one pattern in which we will enable an LED, let it glow for some second and then disable it. Number of times and speed are the same two parameters used in this function. For iteration, add a for loop with user-defined values. Print the number of times LED blinks. Copy the code from last defined function and paste it in this function. Arrange the indentation. Here, you need to enable each pin and then disable the same pin after certain delay. Change the pin number for the remaining pins. Now paste the same code once again. Arrange the indentation. Add the missing time.sleep function. You need to enable each pin and then disable the same pin after certain delay. Keep on changing the pin number till you cover all the pins. Just you have to invert the same. Copy the whole code of this function and paste it once again. Now reverse the pin number in opposite direction. The same pin is to be true and the same pin is to be false for the remaining 15 pins used in this function. Keep on changing the pin number till you cover all the pins. Here we complete our last pattern. Let us give the user the total number of LED blinks. Here, \n means a new line. The message will be printed in a new line. RPI.gpio provides a built-in function, gpio.cleanup, to clean all the ports we have used. It only affects the ports we have used in the development of Christmas light program. Now, here the actual program starts greeting the user with welcome message. How many holds the value for the number of times the LED blinks. Speed holds the delay duration. These are the two variables where we are storing the user input in order to pass these values in function. Here we are calling the first function. This is our second function. And finally, this is our third function. Here we are passing the user input to the functions. The function body is defined above, but we are calling the function at this point in the program. And finally, our program is complete. Let us save it. We have already finished our program. Let us check whether it contains any errors before connecting our hardware. Go to Run and then Run module. We have a syntax error. Let's find out. Here you can see typecasting is missing in RGB function. We have one more error. The module RPI is not defined. As I told you earlier, Python is case sensitive. Let us correct the error. It should be RPI. The I should be in a small letter. Now go to File menu and save the program and run it once again. There is no error in our program. Don't worry for these warnings. This is because we are using the GPIO pins. Now just do a dummy test. You can see the program is executing. We will do real-time test once we connect all the LEDs to the respective pins. Our hardware connection is complete. Let us power up the Pi. If you have any confusion, please refer this diagram. Let us now run the program. Open idle in super user mode. Go to File menu, click on Open and locate the Christmas.py program. Go to Run and Run module. Now enter the total number of times you want the LED to blink. I want 5 times. And the blink duration. I want the delay of 0.1. Once I click enter, this program will execute. Here we go. Each pattern will iterate 5 times. This is the first pattern. This is the second pattern. And finally, this is the third pattern. I hope you enjoyed the Christmas light program. Thank you. Congratulations and thanks for completing the course. Let us summarize what we have learned so far. We learned how to assemble and boot up the mini Pi and also how to use common Linux commands. This course also guides you through the basics of Python programming. You can now create a game using Raspberry Pi and Python and also light up and control Christmas lights. Be in touch with us for more upcoming hardware projects. Thank you.
Playing video files on your Raspberry Pi via command line. If you need to play video files and you don't want to install a full media solution such as XBMC, then you can play them directly from the Raspberry Pi terminal using OMX player. It is a video player especially made for the Raspberry Pi GPU by Edgar Huack from the XBMC project. It relies on the OpenMax Hardware Acceleration API, which is the Broadcom's Video Core officially supported API for GPU audio-video processing. OMX Player is bundled with latest Raspbian image, so you may already have installed. If not, you can install it using sudo space apt-get update and sudo space apt-get install space OMX Player. apt-get update downloads the package lists from the repositories and updates them to get information on the newest version of packages and their dependencies. It will do this for all repositories and PPS basic usage. To play a video file, you just need to type OMX Player space my video, then the extension, example OMX Player space myvideo.mp4. If you are using HDMI, you should use this command to pass audio over the HDMI interface. OMX Player space -o space HDMI myvideo.mp4. These are the different keyboard shortcuts which are used to control the video player. Let us just do a real-time testing of the installation process and video access. Let us just do real-time testing of installation process and video access. Sudo apt-get update. This will take few minutes to update the packages list from the repositories. Let us clear the screen. Now let us install OMX Player. As you can see here, it says OMX Player is already the newest version. This means we already have OMX Player installed on Raspberry Pi. We just need to access our files. Type ls. This will list all the files and folders. As you can see here, we have a file called hardware.mp4. Let us play the file. Let us check, can we play this mp4 format files? Type OMX Player space the particular file name, then the extension of the file. Hit enter. As you can see, we are able to play the particular file. Use the different keys to forward the videos and increase the volume. Thank you. LibreOffice on the Raspberry Pi. LibreOffice is a community-driven suite of programs, meaning the features are driven by what people want to use it for and free to use. It is a good choice for students, small businesses, and occasional users as it should cover all their needs. LibreOffice is able to load and save documents from other Office programs such as Microsoft Office, so you can edit homework and documents sent to you without any issues. LibreOffice is used both on Windows and Linux operating system. Since it is a cross-platform software, we can install this in our Raspbian operating system of Raspberry Pi. LibreOffice is available for the Raspberry Pi at the Pi Store or from the Raspbian packages. The database repository. Let us first update the software database repository. Type sudo apt-get update. Clear the screen. Sudo apt-get install LibreOffice. As you can see here, The total size of LibreOffice is 289 MB and the system is asking, do you want to continue? Just hit Y. The package will install depending on your internet speed. Once the installation gets over, close the Linux terminal. Click on Menu. You can see a sub-menu named as Office, under which we have LibreOffice Calc. This is same as Microsoft Excel. Again we have LibreOffice Writer. This is same as MS Word. You can use it for editing the entire document. And again you have LibreOffice Draw. This is for drawing or creating a new image. You can create multiple steps.